So now we will be discussing about different different types of forcing functions and different properties of Laplace transform. First, let us discuss different properties of Laplace transform. First is the if Laplace transform of f of t is equal to f of s, then Laplace transform of integral 0 to t f of t dt is equal to f of s by s. If Laplace transform of a function f of t is equal to f of s, then Laplace transform of integral 0 to t f of t dt is equal to f of s by s. Second one, Laplace transform of, so now we will see the inverse Laplace, initial value theorem. Initial value theorem, that is, if you want to determine the value of the function x of t at t is equal to 0, at initial value, at initial time t is equal to 0, then limit t tends to 0, x of t is equal to limit s tends to infinity, s into f of s. If you want to calculate the initial value theorem, initial value at t is equal to 0 for the function f of t, that is limit t tends to 0, x of t, then you will calculate using the function, using this value, this theorem, that is limit s tends to infinity, s into f of s. Next, if you want to determine the final value, that is your final value theorem, that is if you want to determine the functional value x of t at t is equal to infinite, that is limit t tends to infinity, x of t, you will calculate using limit t tends to infinity, x of t is equal to limit s tends to 0, s into f of s. So in the question you will be given the value of x of s. In the question he will tell you to determine the initial value for the function whose Laplace transform is s of s is equal to so and so. F of s or x of s or y of s is equal to so and so, he will give you in the question. So in that case, what will you do? You will multiply that transfer function, the transform Laplace function into s, and then apply s tends to 0 for final value, apply s tends to infinity for initial value. Okay. So let me discuss one example so that you can clearly understand this. So these are the properties. We'll discuss one example. Find the initial value and final value of the function x of t. Find initial value and final value of the function x of t whose Laplace transform x of s is equal to s by s into s square plus 2s minus 2. If this is the given, s plus b, s plus 2 you take. Okay, let us find the initial value and the final value of the function x of t at x of s is equal to s plus 2 by s into s square plus 2s minus 2. Okay, so actual procedure is what is the actual original procedure? You have the Laplace transform, you have to apply inverse Laplace transform to the function, solve it, then put t is equal to 0 in the given function for t is equal for initial value, and to put t is equal to infinite for final value if you want. But you have a theorem called initial value and final value theorem, so you don't need to go for this procedure, finding inverse Laplace. If your actual procedure is for this transfer function, you will apply inverse Laplace transform, you will get x of t. In that x of t, you will put t is equal to 0 and t is equal to infinite for initial and final values. But you have a theorems, so that you don't have to go for so long procedures. You can use initial and final value theorems. So to find out initial value, that is limit t tends to 0, x of t, this is your initial value. What you will do? Limit s tends to infinite, s into x of s, because it is function x, right? So limit s tends to infinite, s into x of s is s plus 2 by s into s square plus 2s minus 2. SS gets cancelled. SS gets cancel, you take this s square plus 2. This is just an example. It's s square plus 2. So in this case, s tends to infinity, right? So what do you take? S square common in the numerator. So 1 plus 2 by s square. S square common in the denominator. So 1 plus 2 by s minus 2 by s square, you get s square gets cancelled. S tends to infinity. As s tends to infinity, 1 by s square, 1 by s cube and so on tends to 0. So these values will be 0. So therefore your value is 1 by 1, which is 1. So therefore your initial value for the function x of t is 1. Now final value, to find out the final value you have to do the same thing, but final value means t is equal to infinity. So s will tend to 0. So s into s square plus 2 by s into s square plus 2s minus 2, again s gets cancelled. So what is it? Limit s tends to 0, 0, 0, 0. So 2 by minus 2, minus 1. So the final value is minus 1, initial value is 1. So this is how you apply initial value and final value theorems. Okay. Now let us see different types of forcing functions that are used. That means the way in which you get, you can either give the input to the system, or to study the output of the system you need to know what kind of output you got. If your output is so and so in so and so form, it means it is in kind of sine curve. So you should know what are the curves, what are different functions, cost functions, or it is step input, or it is your impulse response. What kind of output you are getting, in which functional form you are getting, or on what kind of functional input you are giving. Either you are giving in the form of step change, or you are giving input in the form of impulse. In what kind of response you get or you are giving, that is important to know. So the first function is step function. Step function is nothing but function x of t versus time. So at some point, initial point, it will let's say, let us take not initial time you take. At initial some point of time, it will increase to a certain value and remain constant. If this is what you get the response, if the response is obtained in this form, then it is said to be as step function. It is rising to a certain value, remains constant. For example, if you are taking a glass of water, in that you place a thermometer. Initially that thermometer will show 0 reading, right? Or some reading due to some air effect or room temperature effect, it will have some initial value. From that initial value, it will rise to a certain temperature as of the glass of water. Then it will remain constant. See, if it is your glass of water in which you are putting your thermometer. Initially it is having some value, say x. When you place that in thermometer, it will rise to a certain value, right? Then it will remain constant. That is your step response. So for step response, the function x of t is given as a step response. For that, x of s will be a by s.